Hello everyone, myself Snehal Shinde, lecturer in Pravin Patil College of Diploma Engineering and Technology from Electrical Department. Subject is Utilization of Electrical Energy. Subject code 22626, Unit 4, Electric Traction. Here are the definition of the maximum or the crest speed and the average speed. So maximum or the crest speed, it is the maximum speed attained by a train during a run. Average speed, it is the mean speed maintained by a train during a run, and it is given by the following expression, that is average speed equal to the distance between stops or stations, actual time of the run. Schedule speed, it is the ratio of the distance between the stops and the total time taken, including time for stops to cover the distance, and schedule speed equal to the distance between the stops divided by actual time of run plus the stop time. And factors governing the schedule speed will be, first is the crest speed. High crest speed results into increase in the schedule speed. This is because if the acceleration and the retardation are fixed, then for a constant distance, the running time will decrease, and if the crest speed is high and if the actual run time decreases, then the scheduled time speed increases. Acceleration, if the distance between the two stations and crest speed are constant, then increase in acceleration will reduce the running time of the train. Thus, increase in the acceleration will increase the schedule speed. This is considerable if distance between the stations is small. Braking retardation, similar to the acceleration, the effect of braking retardation is to increase the schedule speed. This is considerable if the distance between the station is small. So here is the speed time curve. So the movement of trains and their energy consumption is most conveniently studied by means of speed time and speed distance curve. However, speed time curve is generally more useful because the slope of the curve represents the acceleration and the area under the curve represents the distance traveled. So a typical, and it is plot between the time and speed for traction. On x-axis time is plotted and on y-axis speed is plotted. By analyzing the speed time curve, different parameters related to the traction mechanics can be determined. So first is the notching up period from 0 to T1. The traction motor is started with the starting resistance in the circuit. The starting current fluctuates between a certain value. Tractive effort is constant. Motor speed very slowly increases. So the starting resistance is being cut out during this period so that the current and therefore the tractive effort are approximately constant because of the notching action of the starting resistance. The current fluctuates between the certain maximum and the minimum limits. Therefore, the motor and the tractive effort also fluctuate. However, average tractive effort remains same and hence acceleration remains constant. The speed time curve therefore is a straight line from 0 to t1. Acceleration of the speed curve t1 to t2 after the starting resistance has been cut out at point t1. The train continues to accelerate. The torque gradually falls as the speed increases in the accordance with the torque speed characteristics of the motors. It is observed that acceleration is constant during 0 to t1 and it decreases during t1 to t2. This is because of the reasons like the speed torque characteristics of the motor. As n increases, torque decreases. As the n increases, train resistance increases very much. Hence, the tractive effort utilized for acceleration decreases. As the n increases, coefficient of addition decreases. Therefore, motor torque utilized to generate tractive effort decreases. Next is the free running period, that is from T2 to T3. The train continues to run at the constant speed reached at point T2 and the motor reaches the maximum speed and runs at a constant speed. The free running period is of more duration for long run train and very less for urban areas. So the costing is the T3 to T4. After free running period, the train comes near next station. The supply to the train is cut off and train is allowed to run on its own momentum. So the power is cut off and the train is allowed to run under its own momentum. The speed gradually falls due to the train resistance friction windage. So during coasting, the train runs without any input power. And last is the braking, that is from T4 to T5. So the mechanical brakes are applied along with the regenerative braking. The motor speed gradually decreases till it comes to the rest. So at the end of coasting, brakes are applied and the train is brought to the rest at the end of the run. The acceleration and the free running periods are governed by the speed torque characteristics of the motors. So this parameter should be available for calculations related to the curve portion T1 to T3. The coasting and braking are governed by the train resistance and allowable braking retardation respectively, and the actual shape of the speed time curve will differ from above speed time curve depending upon the various factors such as type of the service, gradients of the different length. So here we explain a speed time curve where it is shown by the graph plotted between the speed and the time. Next is the trapezoidal speed time curve. So the speed time curve of the mainline service is approximated to the trapezoidal speed time curve. So here the mainline service speed time curve and the trapezoidal speed time curve is shown. So the speed time curve for different services are having the different nature. For making the calculations easy, these speed time curves are drawn in a simple way. Some errors will be caused because of the change in the shape, but because of change in shape, but it is negligibly small. So for the mainline service, trapezoidal speed time curve is the closer approximation. So here is the curve, it is plotted. So the mainline service speed time curve is first plotted, and we can see here that it is same or similar to the shape of the trapezoidal in the geometry. So we can make the calculations easier, and it may take some error because of the change in shape, but yes, it is negligibly small because you can see in the figure the mainline service is having a curvy shape at the top, and the trapezoidal curve is the slightly straight line. But we can make the assumption on the formula. So the formula will be divided into three parts. That first will be the triangle part, and other will be the square part in between of the trapezoidal, and next will be the triangle part. So by applying the formula of the area, so the half base into height for the triangle, and then the formula for a square like length into breadth or the side square. So side square formula is applied, then we will calculate the total distance traveled during acceleration, then during the free run, and during the braking. So we will have the three-part calculation in this trapezoidal curve, that is will be the starting, then when the straight is when the free running period, and last will be the braking period. So we will have the different formulas. Then we know the acceleration is the change in the velocity during the acceleration divided by time for the acceleration. So and retardation is the formula, it is the change in the velocity during the retardation divided by time for the retardation, and retardation it is denoted by the beta, and acceleration is denoted by the alpha. So by using this formula, we will use in the distance traveled formula, and while substituting this equation in the formula type, we will get the values of the speed time curve. So the above is the numerical method for finding the speed time value of a particular mainline service. So with the help of the mainline service speed time curve, with the help of the trapezoidal shape, we have found the values of the speed time curve, and derivation is not expected in your syllabus, but we will see, because you will get an idea of how to find the relationship between the retardation and acceleration. So we will see the derivation in detail in the next video. We will see it. Thank you.